Hi, Tony here again. Well, what have I got to show you this time? I've been working on some engine instruments from Electronics International again, similar to the range that I did before. But this one is it's a single instrument, but it's actually a multi-purpose instrument. You can configure this particular instrument to do a multitude of roles. In the real world, you would order the different configuration for whatever parameter it was that you wanted it to measure. But in the Air Manager world, I've enabled a instrument that can be configured for a multitude of different instruments. So let's start it so you can get a flavour for what it's all about. So it's kind of on the back of something I was going to do anyway, but got sort of inspired to do this one after seeing what Russ Barlow had managed to do with the adjustable airspeed indicator and the I think the tacho instrument that he's did, and that kind of reminded me of this engine instrument that I still needed to have a look at, and so I've been tinkering with that for the last few days to produce this. So what you see here on the Air Manager user properties tab is a list of quite a lot of user properties that can configure the settings for this particular instrument. So every single one of these obviously forms the basis of, you get a 7-segment display at the bottom here with the value of the parameter, and you get a needle arc type display of about 210 degrees, where you can adjust the segments and you can adjust the text and you can adjust pretty much everything, color bands, you name it. So we'll go ahead and have a little play with some of these parameters, and you can see how they affect the generation of the instrument. You can see at the moment I've just got some random numbers and words in there as we've selected tacho here. You can see they're currently overlapping a little bit here, but we have a way to fix that without actually doing any coding at all. It's all done within the user properties, which is I guess good if you don't want to get your hands dirty with code. So let's just have a look at the list then. So the very first parameter that we choose here is the type of instrument it's going to be. So in this particular case, you can see it's a tacho, but we've got a choice of M1, NG, N2, MP, ITT, TOT. So some of these are the same thing, they're just different names for the same thing depending on the type of aircraft that it's fitted to. Some engines refer to it as M1, NG, etc. Same with the TOT. Oil temp, carb temp, OAT. Where was we up to? Well, anyway, we don't have to sit and read for all of them, but you can see there's loads of temperature, volts, current, fuel flows, fuel quantities, torques, and then a ton of pressure ones here as well for all different things: oil pressure, fuel, manifold, hydraulic pressure, cabin pressure, etc. So lots and lots of instruments, lots and lots of things that you might want to monitor. Based on the real world instrument in terms of the ones that they do, but also what's available within the various sims that we can get data on and actually use to describe. So some of these parameters I've had to be quite creative in terms of how I generate the actual output for the gauge, because some of them are not directly available, so I've had to work it out by using a combination of a couple of them. But yeah, they seem to work out all right. So if we just base it on a tacho gauge then for the purposes of this, but you can see I've got a little panel when we finish at the end of the video, just to show you I've set the user properties on I think it's a cluster of 8, like you'd get in a typical engine instrument cluster, with the different gauges for a turbine. So I've got a cluster of 8 gauges set up all differently with the user properties, but it's the same instrument essentially, but just configured in 8 different ways. So we'll concentrate on the tacho one for the moment. So similar to what you may have seen before with Russ's tacho, except for obviously you can choose lots of other different instruments too, is you've got the tacho, you choose the units, then is the next thing to choose that you want the tacho to display. Now it's got some logic in the code that basically will exclude you from being silly and choosing units of amps, for instance, to measure tacho. So you have to obviously actually choose something that's within the realms of what you would use as a unit for that particular instrument. So obviously RPM is the obvious one for tacho. And then if it's applicable to your instrument, depending on what it is that it's measuring, in this particular instance it is applicable because we're asking for the engine that we're going to be measuring the RPM from. So in this particular case it's 1. There's a choice of 9, not because there's 9 engines, but I think there's 9 fuel tanks, I think it is. So depending on if you were doing fuel quantity, for instance, then that would pertain not to an engine but to a tank. And for the electrical ones it pertains to a bus. So you choose the number based on the type of instrument that you're selecting. Now in here we have a couple of fields now which give us and depending on the unit, the type of instrument and the units that you choose will depend on what appears here on the fascia of the instrument. So the name, in this case we've chosen is tacho. They're not always exactly letter for letter the same as what you choose here. Some of them have been abbreviated because they're quite long, but that is what gets chosen based on that choice. And then this choice here is what gets chosen here, which is the RPM. The times 100 is another user parameter down here somewhere, where basically if you choose not to choose a 1-to-1 scale, whatever scaling you choose, it will append onto the end of the units here. So if I weren't to choose the times 100, it would just say RPM there, and these were obviously had another lots of zeros on the end of them to give you the actual real numbers with 2 zeros on the end. So with this alternate gauge type text, we have a couple of ways now of overcoming this problem. You see where the numbers are clashing on the text there. Either we can put some alternate text in there. So I could, for instance, just write the word tack instead of the default tacho. And when I rerun the instrument, you can see now that revised word. So if there's a blank field there, it will use the default. If there's any text written in there whatsoever, it will put that in there as the name. And the same with the units. I can change the units if I so wish, and that will put whatever I type into the units field in here. So again, a way of modifying the actual the text so that you don't get this clash. Still a little bit tight there, so we have some other parameters further down where we can shift the position of these things down just to make the instrument look right. So quite a bit of flexibility there. In fact, they are the very next parameters. So we've said the name text vertical position and the Unix text vertical position. So I think I've allowed about 20 pixels here. So they're on 0 at the moment. So just for demonstration purposes, if we say 20 for the name, and we ought to shift the units as well, otherwise the name's now going to be overlapping the units. And then we rerun the instrument. You can see now they're shifted down by 20 units, both of them. I could shift the name one back up. You get the idea. I think we'll change that to about 15 or something like that. Yeah, it doesn't look too bad. Okay, so there you go. So you've got a bit of flexibility again with the positioning and with the naming of the text, so that you can get it to fit on the fascia of the gauge, depending on how these numbers auto-generate, and depending on how many major and minor tick marks you've got around the outside. So those settings are coming up next. So that's the text position. There's a couple of parameters here that one of the units you probably saw when I used the drop down list there was percent. So for some of these either the data is only available in percents, and you may want to display it in RPM, so you have to tell it what the maximum is. So 100% would equate to whatever this maximum RPM is, depending on which way around the units are. And a similar thing, I think, with the torque figure. I think that one is the opposite way around. I think the value is available in the actual torque, and you may want to display it as a percentage. So there's a couple of options there for putting for putting those particular parameters in, if they pertain to the type of instrument that that you selected up there. The fuel type, that's related obviously to the fuel related gauges. It doesn't really matter and doesn't make any difference if you select jet A1 or avgas if you're not using a fuel type instrument. But if you are, then from a fuel weight perspective, it needs to know if you're an avgas aircraft or you're a jet fuel aircraft for the calculation of the fuel weights. Show panel surround, that's fairly self-explanatory. That's this grey bit around the outside. That will just turn that on and off. We've got it turned on at the moment. And then instrument power electrical bus, that's the electrical bus within the sim. I think that's just fixed on one for FSX, but in X-Plane you get a choice of 6 electrical buses depending on the aircraft, of course. So predominantly it's going to be one. So when we power up that bus 1 and that bus 1 has power on it, then this instrument will have power on it, and will only get power from whichever bus you select there. So if you select a bus that never ever gets power, then the instrument won't ever power up, so you need to make sure that that's the right one selected. Then we get into the settings for the actual the arc and the tick marks here. So we set a minimum. It is possible to set a negative value in there. So for something like an ammeter, you could set a minus current and a positive current at either end of the scale, and perhaps a 0 in the middle here. So you could indicate positive and negative charge and discharge. We've just said 0 here, as you can see in this example, and you can see the scale maximum for the purposes of this RPM tack gauge is going to be 3000. That's 3000 RPM. You can see in the very next user property box, we've got a scale multiplication factor. So it applies that multiplication factor to that 3000 when it's displaying these units here. And as I said earlier, depending on what this says, it will add the times number on the end. So if we were to change that to 10 and rerun the instrument, as what you would expect to happen, now it says times 10 in the middle, and these numbers have added a 0 to them because now they're 10 times larger than they were when it was times by 100. So let's change that back to 100. So again, you've got different possibilities there in terms of the types of instruments that you could scale for. You see that on quite a lot of instruments with the times by 100, obviously, because if they've got a large amount of digits, you may not want to show them. So you just show them as 30 and say times by 100. Then we choose the number of major tick marks. So the number of major tick marks I'm including as the start, and the finish one is obviously as a minimum of 2, and then obviously including the ones in the middle there. So you look at the instrument that you're trying to base it on, and if you look at the tacho instrument in the default 172 in X-Plane, you'll see that at least I think 1, 2, 3, 4, 5, 6, 7, 8. So it has 8, yeah, because it goes up to 3500. So okay, I've used poetic license there, and I've altered it ever so slightly. But you can do whatever you need to do there. So you choose a major tick marks number, and it will use that number of major tick marks. So 7 we've chosen. 1, 2, 3, 4, 5, 6, 7. There's the 7 major tick marks, and then the next one is minor division. So that's basically saying within each major tick mark, how many divisions have we got? And you can see we've got 1, 2, 3, 4, 5 divisions in between each major tick mark, so they'll all be spaced the same. So 5 tick marks. Using all that information and some clever maths, well, not that clever actually, it's only angular stuff, it's not that complex. Based on the overall 210 degrees, it will space out your instrument for you, and based on your minimum and maximum scale, it will work out what these major tick marks numbers need to be, factoring in the multiplication as well. So taking all of that into account, you see this auto-generated major and minor tick marks here. You can see if I were to let's just change them quickly just to show you that demonstration. Let's 2, so 5 major tick marks and only 2 minor divisions. Let's give that a run. There you can go. So we've only got the 1, 2, 3, 4, 5 now, and we've got only 1, also 2 minor divisions in each thing, and you can see these numbers have changed accordingly. to evenly space between 0 and 30. So you need to think about that, and obviously a normal real world gauge probably wouldn't be. You can see these numbers are a little bit 7 and 15 here, so that's actually not half of 15, because it would be, you know, 7.5, but it rounds, so there's some rounding going on here with these numbers as well, so that's why they're a little bit out. But in the real world you probably wouldn't ever see an instrument like that. That's just for the purposes obviously of this demonstration. So if you base it on the real instrument, the numbers are going to come out correctly. So let's go back to what we was we? No, we was 5, wasn't we? There you go, so back to 5. So you can see how you can sort of get the major and minor tick marks to be what they need to be. The next setting, digital display resolution. So the digital display refers to this digital display. Depending on the parameter that you're measuring, you may want a resolution of 1 or 0.1. So you have the option to put a decimal point here, essentially. So this becomes the 0.1 display on the end here. But obviously, if you've got a large number that goes up to say 3000, like in the case of this tacho, you're going to just want the resolution of 1. So we've got the display resolution of 1. You can see the other option there is 0.1. And then we get into the ranges. So I think I've allowed, is it 7? Yeah, 7 ranges, all defined exactly the same. Each one is set up with 4 parameters. So you see range 1 there, range 2, range 3, etc. And they're all asking for the same information. So essentially you give it a type here. So you either tell it off. These are the coloured ranges I'm referring to here now. If you want colour ranges, that is, some instruments you may decide that you don't need the colour ranges, in which case you just leave all these set to off. Off is the default, but then you have the option of saying full or rad or radial in terms of the type of dial that colour bar it's going to be. So if you choose a full, that will be a full colour bar going round in an arc there, depending on between what numbers you tell it. So I've said I want a full type, and I've said I want it to be green. You have the choice of yellow or red as well. And then I've got a low and a high. So the bottom end of the green I want to start at 0, and then the top end of the green I want to finish at 2100. So we should see a green bar start here from 0 and go all the way up to about here 2100, somewhere like that. So if we go ahead and leave the yellow one off for the minute, so we'll just add the green one in there. So there you can see now you've got a green bar all the way over to 2100, and that's what we class as a full bar. Then we're going to go ahead and turn the yellow on. So then the yellow on this particular instrument, we want to start at I don't know, let's say we're going to carry on from the 2100, so 2100 up to say 2500, which is what we've got here. So we want a full bar again, and we want it to be yellow this time. So let's go ahead and run that. Now you see we've added in the yellow bar, and then the last one we need for this particular, so you've got 7 of these, but we only need 3 for this one. So for the third one, just to give an example of this one now, rather than a full bar, we're going to say we just want a radial. Now for the purposes of this one, you only really need the first number, because when you select rad, it only ever takes the first parameter, because it's just putting a radial type marker on here at that particular value, so it ignores the high value. So it's kind of irrelevant. You could leave that at 0 if you wanted to. It wouldn't make any difference as long as the number here in the low box is the right value. So at 2500 we're going to say we want a red radial line. And the beauty of this red radial line is similar to a lot of instruments that I've seen, is you can actually overwrite the red radial. You can overwrite the white now, because this colour is drawn, or certainly for the radial, is drawn over the top of the white scale, whereas the other colours are drawn under the white scale, as you can see the full colour. So when we press there we go. So you can see now the red radial, because it's exactly on 2500, it draws a red bar there right in on the 2500 mark, saying that that's your red line for this particular tacho. So there's the coloured arcs. So you've got up to 7 of those to choose from. And then the last few parameters are just the choice of the instrument dimmer number and the panel dimmer number for the lighting effects, similar to my other gauges that I've shown before, and some other lighting controls for the auto lighting control. I think that basically when you get to a certain darkness in the sim, the lights will automatically see that and come on in terms of the type of lighting, if you don't want to use an actual dimmer for that. So some of these functions may be more useful for FSX or maybe more useful for X-Plane. You have to have a play with them. It was a while ago since I coded all this lighting stuff, but it's in a library file that I use for most of my instruments, and it seems to work quite well. And then use photo cell. So this on the real instrument, this is a photo cell here in the front of the fascia of the instrument, and that senses the ambient light. So you can get it to sense the ambient light and automatically adjust the lighting for the lighting conditions. So if you're flying at night, this will dim down a little bit and not be quite so bright with this display and the actual overall lighting of the instrument and the arc. So there you go, that's the instrument. Let's go ahead and power it up. We haven't even seen it operational yet. So there's I'll switch the power to the bus that we've got configured here, and you can see the needle will then come up. So the needle is a little bit damped as well, so you can see going up to a value there, and you get the readout on the display at the bottom there, and you get quite a nice movement of the dial there, damped. So if you were to, for instance, switch the power off again, you get a nice slowly damped needle down to the bottom there, rather than an abrupt just draw it in the off position. A bit like the real instrument would react. So let's turn that off. Now we've looked at that nice big instrument, and we'll just go to the panels tab very quickly, and we'll turn off this little turn on this little cluster that I was telling you about at the beginning. So you can see here now, this is exactly the same instrument in all cases here. How you can configure them to be different for different aspects. It would help if I actually went to the right aeroplane. I think that was the 172 I was in just briefly there. Yeah, I think this is a King Air, so this is just one set of instruments for the King Air. But I think a lot of these values were taken from the King Air gauges. So you can see we've got the TOT or the ITT there. Torque over here with just a single red line. That one's got two red lines, so they're all slightly different. That one just has a green arc and a red line. And you can see the difference units there. That's a percentage, that's RPM. This one's just fuel flow. No, sorry, that's fuel pressure. That's fuel flow. That should go up quite a bit when we give it some. Yep. And then we have oil temperature and oil pressure with a yellow arc and 3 red bands. That's just how it is in the sim. But you can configure the different instruments to get yourself a cluster similar to this one. Reasonably easy to do. This is actually all done using the canvas. So there are no images for any of these bits. In fact, just reminding myself, I can't actually remember. Yeah, I'm not using that. Yeah, I think there's just a mask or two for the needle and the bezel and the panel surround, and that's about it. So there isn't any other drawing objects. This is all done with these tick marks, and the color bands are all done using the canvas to add those very, very flexible enables you to manipulate and draw wherever you need to, and you can kind of do it, you know, sort of not dynamically, but based on these user properties. You can adjust the look and feel of the gauge just by changing a few parameters. So thanks for the inspiration, Russ, with the adjustable airspeed gauge. These were some that I said I was going to look at for a while. It just gave me the impetus to drag it out again and get them operational again. Perhaps these gauges would be useful to set up a generic panel for a certain instrument, but they do exist in the real world. The Electronics International, as I said, and quite nice with the digital readout on the bottom. But you could adapt them or use some other concept if you needed a larger arc or some different thing. You could, if you were really going generic, do away with the digital display, and you could even choose the start and finish positions of the needle. Would need a little bit more code, but I'm sure that would be possible to do that. So that basically you could have a custom start and ending point for your needle, so it looks even more like the real instrument. But anyway, that's the customized engine instruments, just using user properties. Thanks for watching. Join me again soon for another video. Thanks.